So I'd now like to introduce our Director of Innovation, Cynthia Bouthot. Commercial innovation.
Thanks, Warren. So I am going to talk to you about the demand side of the equation, and first and foremost about our portfolio. When we think about our portfolio, we think about it in these 4 vertical areas: life science, physical science, technology development, and remote sensing. A big part of what we've done to develop our portfolio is to look at each one of these areas and actually develop propositions or products that we talk to our customers about. So in each one of these categories you see on this chart, we actually have done a lot of work to develop these products and propositions and talk about them in the way that our customers talk about them, in the non-traditional space sense. We've also done a lot of work to identify the value and impact criteria. So you heard both Greg and Warren mention value impact and how it's infused into all parts of our business. When we talk about our portfolio, it goes hand in hand with value impact. And the way that we mean this is we look at everything from an economic, innovation, and social benefit side measured against feasibility. The construct looks like this. The impact is on the y-axis, low to high, and the feasibility is across the bottom. Ultimately, we are targeting 3 of these quadrants. We're looking at those high risk, high return projects. We're looking at optimal, which are the high impact and high feasibility. We're also in attempt to drive utilization, looking at the volume type projects, those that might be the quick hits that are high feasibility and on the quick horizon. It's important to note that we are addressing a balanced portfolio attempt where we're looking at having projects across all of those dimensions. And it's also important to note we're looking at managing the portfolio. So when a project is higher risk or lower impact, we're hoping over time to help move those projects to the right and up. And that's a big part of our portfolio management process. This is a view of our current portfolio where the green bubbles represent the approved projects. The size of the bubble represents the total cost of the project. The red ones are the ones that we did not accept. Now, we know we can do better in this because we see a lot of the projects in that top right quadrant. We might not be taking enough risk and have enough projects in that top left. Those are those projects that could be the game changers, the really big, hard projects, the ones that are difficult to do, but that could potentially result in very great return. We also know we have to do more in that volume quadrant, those quick hits, to ensure full utilization, as Ken is going to talk about in just a minute. Warren talked about the fact that we're leveraging value impact in all parts of our operation. And that is true from a customer targeting perspective. So this is an example where I showed you those propositions at the beginning under each one of our verticals. When we talk about high risk, high return propositions, those are things like on-orbit production or tissue on chip. We know we want to focus on those, but we know that they're harder to do, so we take that into account in our targeting. In terms of the optimal project, the high feasibility, the high impact, those are things, and again, in life science as an example, like the cell biology or the delivery systems and manufacturing optimization type projects that we have come through. And then in terms of volume, we have identified macromolecular crystal growth and microbial studies as those types of life science projects that are those quicker hit and those projects that could fill up our volume bucket. So as both Greg and Warren said, it's about value impact and utilization for us in this balanced portfolio approach. We're also using value impact as we review every project that comes through. This is an example where we have every one of our metrics. We have 13 measures. 9 of them are impact, 4 of them are feasibility. This is just what one of our review results looks like. The red dots are where the project actually scored on that measure. And then we ultimately use that to place the project on the grid. So value impact is being used to review, and it's the construct that helps us to select the project. And again, as we talked about earlier, hopefully move those projects that are lower left up and to the right. Now I'm about to talk about some future projections, so I need to read the safe harbor statement. The conclusions herein are based on qualitative data and information that include estimates, projections, and subjective judgments. No assurance can be provided that the final results, outcomes will confirm these estimates. CASIS will update these conclusions periodically to reflect newer data and information as available. The final part of what we do with value impact is we use it to communicate the results to our stakeholders. This is just a sample of some of those results. Our project, and again, these are self-reported by the organizations doing the research, and they're validated by our subject matter experts, and once a year by our expert panel that come together to review our projects. And to date, we have projections of about 1.5 years of accelerated time to market. And that's measured from product concept to the time that the product becomes commercialized. We have reported expected $900 million of incremental revenues tied directly to the project conducted on station. It was estimated that we have an addressable market of $110 billion. An addressable market is that market which is directly tied to the opportunity related to that product or service, and it's an indication of how much incremental revenue can be achieved from that project. And so obviously 110 billion is an indication that the markets are big related to the projects being conducted on station. And the last one I'll note is new solution pathways, which is one of our innovation measures related to new IP or a new knowledge or a new way of actually conducting something. So it's a new pathway related to innovation. Ultimately, we're continuing to gather information from our projects and continuing to communicate the value and impact of what we're doing. But we have, just as Warren started, we have challenges and we have learned lessons as we've gone through this process. It is not easy, and for those of you that are sitting in the room providing us this information, thank you for that, because it is not easy obtaining the value impact measures related from the project. We need to do it at the beginning to actually be able to assess your project, and then we need to do it throughout the life. Once your project lands and you're operational, we need to continue to get this data so we can go from projected to actual results. So we'll continue to work with you on that one. Those perspective views that we've talked about are not as credible as the true retrospective results. So that's why it's really important for us to continue to gather this data and to report it back out as actuals. Achieving that balanced portfolio that we were talking about earlier requires us to actually look at those higher risk projects or those lower impact projects. And it's not always easy to balance that portfolio to share that risk. So again, that's something that we're working on. And NASA has been very supportive in terms of when we do see these very high risk projects, we work together to see how we can actually mitigate the risk to move forward with those. It does take long sometimes when we're working with Fortune 500 organizations or commercial projects to actually, the first time you have that conversation about doing something on the International Space Station to the time that you obtain a project proposal, those are long sales cycles and there's long conversations. It's not like we're selling a widget. These are very detailed discussions. They take place with big groups of people within these corporations. We're working on improving the time it takes from those first discussions to a time we have a project proposal, as well as everything we do to support that process. We understand that there's limited time left on the ISS National Lab, and we know we need to get projects in now. So we're doing everything we can to accelerate those times to project proposal. And then ultimately, I mentioned we have an external panel that meets once a year. These panelists are not paid. They volunteer their time to look through our portfolio. It's imperative that we continue to engage with the level of experts that we have been doing to ensure that we have the credibility with our review process. So that's something that we look to this board towards. And I think as you saw the board introduce themselves, you are subject matter experts to us as well as we look at these projects. And Joe Formicelli, when he started, didn't mention that he actually, in his role as head of operations for IBM, has been a big help to us in terms of implementing this assessment process for cases. And I'll just finish off with 2 examples. So Warren gave you some of the customers that we talk about in 2018 and 2019. This is a list of customers that were accepted in fiscal year 2017. And you'll see a broad range. You see Fortune 500 organizations like Budweiser, who are flying barley. They're going to understand the stress conditions of barley. And, you know, in addition to beer, barley is the 4th largest crop related to cereal production in the world. So what they're going to learn there will have broad impact for food production here on Earth. You see the Boeing Mass Challenge projects. So we don't just work with big Fortune 500 organizations. We have a lot of small companies coming in through these accelerators or competitions. You see 3 examples there. And Dover Life Science, similar to Michael J. Fox, are looking at crystallizing proteins that are very difficult to do here on Earth. What Dover's focused on are obesity, rare conditions, and cancer. And as we know, Michael J. Fox is focused on the LRRK2 protein related to Parkinson's disease. I think that you'll see in our list of new customers from 2017-18 and the ones we're looking at for 2019, they span our whole project portfolio. So we are seeing projects in the life sciences, the physical sciences, the technology development, and the remote sensing, and we expect that to continue. And then finally, sponsored programs. It is the model that we pivoted to from a philanthropic fundraising model, which was not successful for us. Sponsored programs is the way that we talk about using the International Space Station to solve a big problem here on Earth. And it's also the mechanism we engage in public-private partnerships with the OGAs like the NIH and NSF. And they have been really good partners for us, where we're doing great work in organ-on-chip and fluid dynamics and combustion. We've also seen great progress recently with commercial companies that are looking at their corporate social responsibility goals like Target did. They looked at cotton, more efficient cotton production, which was one of their corporate social responsibility goals. They put in $1 million, and we are now executing an open innovation challenge that's focused on seeds, better crops, better crop management, water technologies and solutions, and also remote sensing solutions. And we're very excited to be working with them on that. You can see by the cumulative sponsored program funding that we are ramping up, and just over a couple of years, we have seen success in this independent money coming in to solve these big challenges. So hopefully you got a view of the portfolio approach, how we actually develop the propositions, the what we do, the value impact process, which is the way we manage our portfolio, and then a view of some of our customers and sponsored programs. And now I'm going to turn it over to Dr. Randy Giles, who will talk more about our portfolio from a science standpoint.
Thank you, Cindy. Thank you, everybody, for coming here today. I didn't realize that I was such a popular speaker. What we have today is a stuff of science fiction 50 years ago. we have an international space station, which gives an opportunity for doing unique experiments and research in the persistence microgravity of space and in the extremes of space. But before I get into talking about some of the projects that are going currently on station, I'd just like to remind ourselves in terms of the volume of the projects and publications that have been going to the station, being published here on Earth. Over the past 6 years, there have been 190 projects that CASIS has fostered and put onto station. During that same period of time, we've had 108 peer-reviewed publications, which is an important measure of the productivity and the validation of the results in the scientific and engineering communities. So let's get started to talk about remote sensing. That's the first example of the types of things that are done on station. Now, we know that there is already a lot of space satellites out there which are providing observations of the Earth which we use today in our daily lives. But what the National Lab does, it gives you a flexible platform for doing your technology development and early testing of new technologies. It also gives you a return capability during that development phase. There are also, of course, interests to do commercial exploitation of the vantage point that the space station offers. Now, this particular slide is showing the measure of algal blooms in coastal ocean waters using HICO, the hyperspectral imager of coastal oceans. This type of data has actually been commercialized using software that was developed at the Naval Research Laboratory, and it's helping us to better understand these algal blooms, how to mitigate the risks they create, and the hazards they present in our coastal waters. We are also very much interested in technology developments. One great example of that is the work that is being done on fluoride optical fibers, where it is believed, and we're finding out now, that you can get fibers of unprecedented quality by drawing them and making them in the microgravity environment. Now, these fibers could potentially revolutionize optical networks. It could potentially revolutionize medical systems using laser-based therapies and technologies. It could even possibly revolutionize missile defense systems. Now, those fluoride fiber guys out there, I want to remind you of something too, is that the inventor of the silica optical fiber, Charles Kao, received the Nobel Prize in 2009. So my advice to you is set your ambitions high, get that 100-fold improvement in your optical fibers, and maybe there's some reward at the end for you as well. So we also look into the areas of drug discovery and delivery. In fact, the life sciences is our most lively vertical, having an extraordinary breadth of activities in drug development to disease modeling, from using single cells to whole organisms. One example in drug development is the crystallization studies being done by Merck on the anti-cancer drug Keytruda. Now, if you don't know, Keytruda is an extraordinary immunotherapy drug that has transformed the cancer treatment landscape. Merck's research is focused on a better delivery of Keytruda by having it in a form that can be delivered by simple injections rather than intravenous drips, which would greatly improve the patient comfort and lower the medical costs. Now, we'll also be soon flying 5 experiments of tissues on chips, which are to mimic the human physiological system on a tiny scale that will enable new ways of doing drug screening and testing before going on to human trials. Last year, we had an experiment done on station for cultivating human heart cells, which is absolutely fantastic. Last week, I listened to Dr. Fraser of Baylor Medical College speak about his research and work in heart transplants. He has the world record of transplanting more than 1,100 hearts in patients over the decades. Now, at the end of his talk, he showed a picture of the most advanced artificial heart pump in the world. It's a marvel in technology, has a single moving part. And in fact, what's kind of interesting to learn, you don't even need to really have a pulse from a pump like this to stay alive. But now, with the research that's being done on the station, is that we're looking to possibly have things that will be even further advanced from an artificial heart, like what Dr. Fraser had showed, where it would be something that could be possibly tissue grown on the space station and brought back to Earth to aid those who are having serious heart diseases. And so in that case, you don't have to worry about the organ donor shortage. You don't have to worry about the potential of rejection. And all this will be done organically. Now, in the area of disease modeling, we do a lot of other activities on station, because in the microgravity environment, the human physiology is challenged. You have bone loss, you have muscle atrophy, and these can be occurring at an accelerated rate, mimicking aging, but again, like I say, at an accelerated rate. So what we do is that rather than doing direct experiments on humans, we also send mice up to space and study them to look at the effects and influences of drugs and treatments that might be then ultimately used for humans here on Earth. Now, these mice don't roam the space station freely. We actually have a high-tech hotel, as shown in this picture here. And in this hotel, there's food, water, air, waste disposal, and of course, all the tools and techniques for actually monitoring and measuring these mice so that the experiments can be conducted. It's not an easy task in microgravity. It's not. But it is very important. And also, I'm sure that the mice appreciate it. So let's just talk about several examples of the rodent research that's done on station. Recently, the Indiana University School of Medicine and the U.S. Department of Defense used mice to evaluate new therapies for fracture healing and bone regeneration. UCLA researchers tested an osteoporosis therapeutic on mice to treat bone loss. Eli Lilly scientists used rodents to study an antibody to counteract muscle wasting. Houston Methodist Research Institute and Novartis are using mice to investigate nanochannel technology for controlled drug delivery. And Dr. Gattoni will speak later more detail about those types of research. Now, the space station is also a wonderful platform for doing discovery science, where the results can be really surprising. Last year, at last year's public board meeting, I spoke a little bit about the alpha magnetic spectrometer, which is shown in the lower left figure of this slide. This is a $2 billion particle detector. And from it, we're learning absolutely new and marvelous things about the universe that we live in, and we will learn more. It's an amazing tribute to the inquiring man's mind of humanity. Researchers at the VA Medical Center in San Francisco discovered a new mechanism of immune regulation by microRNAs, also a potential revolution in the life sciences. Researchers from the University of Florida discovered a previously unknown mechanism of plant root development that could lead to better crops on Earth and in space. Now, space is cool, and we got to get our young children interested in science and technology. So we have, in the example shown here, the Tomato Sphere program, which is a project-based learning. Last year, it reached out to 500,000 students in 20,000 classrooms, where they got to germinate tomato seeds that were sent to the station and brought back to Earth to look to see if there was any influence on microgravity on their growth. The Zero Robotics program has high school students programming floating robots that are on the space station. How cool is that? If only I was younger than what I am today. All right, looking ahead, The R&D at the National Lab is building pathways towards a new space economy and low Earth orbit. Space platforms already provide navigation, remote sensing, and communications of incalculable value. Where can we go from there? What about GPS with centimeter resolution? You know, the GPS you have today does not know if you're actually driving in the right lane. You don't know if you're actually headed towards the oncoming traffic. It doesn't have that resolution capability. Your map software thinks that you're in the right lane, but the GPS does not. Maybe we can improve upon that. And what about having a real-time Google Earth? Wouldn't that be cool? So then, now, I want to show you something here. In my hand is a text communicator. It communicates with the Iridium satellite constellation. It communicates with the GPS systems. It gives me text messaging anywhere in the world, and that's really cool. It even has an SOS button that might save my life. But what I really want, and what I think all of you really want, is a satellite smartphone that gives you broadband internet anywhere in the world. And maybe with that SOS button that could save your life. Now, the production of high-value materials in LEO that will return to Earth as tangible, sellable goods is coming soon as well. I already mentioned the fluoride optical fibers, but other advanced materials are in the pipeline, and even human tissue could be returning to Earth from low Earth orbit to serve new industries and the U.S. economy. And I want to leave this as a last reminder. The National Lab is open for your ideas, your research, your development, your problems. So come and talk to us. Thank you. And now I want to ask for our Director of Operations, Ken Shields, to come to the podium.
An important point that Randy finished with here, and that when we use the word "we," what we're really talking about is just a burgeoning, exploding economy that is reaching into space as a new dimension. And we really goes much further, and we are, all of us in this group at CASIS and supported by NASA, we are also supported, and the real efforts are coming from a variety of ideas in the science field, from other participants, real innovators and small companies that are pushing. Many of those got a start with NASA. NASA has a history of creating innovation and obviously moving it in the direction of commercial activities. So when we say we, it's a brilliant structure that is coming on at a terrific rate. And that our job here is to help facilitate that effort. We're marriage arrangers in many ways. What we put together are some brilliant young company that may have started in NASA, might have started with a SIBR, or it may come from the NIH or other places. And I know that our message is coming across that way, but it's worthwhile saying that explicitly, that we are a movement and we're helping that with our customers. And frankly, I'm really proud of this team. That doesn't take away with what the team is doing, but you're going to hear now from Ken about commercial partners and others who are all part of this effort. And of course, many in this room are part of this effort as well. So we are interested in your ideas as much as any. So thank you.
And thank you, Abe, and that was a great message. And in all honesty, I'd like to sit down and just leave well enough alone because I'm afraid I'm going to mess it up. That was, I mean, that was kind of perfect. So bear with me as I try to struggle this up and not muck up what General Abramson was just getting across. So I'm Ken Shields, and Randy, that was a great presentation. Thank you. You really are a cool presenter. And it's cool, that phone that you want. I want a new pickup truck, but that's not the topic that we're on. We're going to talk about utilization. I'm going to talk about utilization today and try and look at utilization in a different way and try to understand how utilization tells us about how the National Lab has evolved. And what is utilization, first of all? Well, it's a fancy way to say use or use. And how we view utilization, both NASA and National Lab, we look at utilization and try to understand how well are we using the resources that we have at our disposal. How effectively, how efficiently are we using them, and are we producing the desired results? Are we producing valuable impacts and results through utilization? So that's the way we look at it, and we're going to explore, take a deep dive here in a few minutes on several of the metrics. A couple examples here that you could see. 200 plus payloads delivered to date. That's from 2012 to today, have been delivered to the ISS under the sponsorship, under the facilitation and enablement of National Lab. That's really been our role there. And those 200 plus payloads have utilized in excess of about 1,600 crew time hours, and in fiscal 17 alone, almost half of that. So we're seeing some tremendous trends. And now, having managed the laboratory for 5+ years, we've got some very interesting data that we can look to suggest to us, once again, telling the story of how the laboratory has evolved and perhaps giving us some insights on what we can predict for the future. And also, what has the utility of the laboratory been, and who is it servicing, and what can that tell us about what the future might look like? Once again, having 5 years of data, I think, gives us some important insight and allows us to make some predictions into the future. So let's start by portfolio growth. And what we mean by portfolio growth is the growth of CASIS selected projects, which are projects that have been sourced through CASIS outreach efforts, commercial innovation, meetings, conferences, partnerships with OGAs, with solicitations, things that have come through the CASIS review and selection process. And as we can see here, we've seen a nice steady growth trend over the past 5 years that's been proportional. Important to note here that fiscal year 17, we're close to about 200 projects in the queue. And important to note that's pre-flight, flight, and post-flight. Roughly half, maybe a little over half, are coming from commercial, and the balance is non-commercial. We're projecting that over the next 5 years, we're going to see growth to nearly 400 projects in the pipeline of similar proportion. And to us, that's an indication that the laboratory really is serving a very useful purpose to a broad spectrum of interest and project sponsors from different types of organizations. But it's only part of the story. Once again, those were CASIS selected projects, and what we've seen as of late is tremendous growth in the area of commercial service provider expansion and implementation partner growth. And these companies and these individuals are now contributing significantly towards resource utilization and important results, important valuable impacts of the projects that they're working on. And these companies aren't simply technical experts in the area of payload development and payload integration and hardware development, but they are also key stakeholders and key partners in this whole initiative of having a national laboratory. They're really empowered partners that inform not only national lab operations and processes, but they also have a lot to do with informing NASA on what they should be thinking about. And I can tell you this, we've gotten great support from our colleagues at NASA on resources that we need, capability expansion, transportation. So it's just a fantastic time to do space-based R&D. I don't think there's ever been a better time, and a big part of it is due to these partners that we have in space R&D and with the National Lab. I want to mention that twice a year we hold workshops with this group. Today we're holding our first workshop of 2018 after this meeting this afternoon. So we're looking forward to sharing in an open forum, open dialogue, getting some inputs on what we're thinking about in the future and how we'd like to enhance operations and processes to help their business and help us to utilize resources for valuable impacts and results. A subset of these commercial facility providers are commercial facility operators. Now, this is a fairly specialized group of companies who actually design, develop, and deploy hardware, assets, facilities on orbit to host and operate payloads. This is the example of where we are now. Over the past 4 years, we've seen some nice steady growth to where we now have 12 facilities on orbit that are in operation, commercial facilities, bear in mind, and pause and think about that for a little bit. These are facilities that are built with capital, speculative capital from companies who are taking the risk in investing their time and their effort and their resources in deploying these facilities on station. And they're sustained by a user model, a traffic model from several different types of project sponsors, industry, OGA, et cetera. 7 companies, once again, operating 12 facilities now. We're projecting 5 years from now, we could see upwards of 25 commercial facilities from maybe 15 to 20 different companies. Important to note that they are also pushing the boundaries. These are the guys who are bringing the state-of-the-art to station right now. They are really heavily involved, in a sense, in us renovating the laboratory. And maybe most importantly, certainly important, that they're also decreasing dependency on government subsidies in this area. So big push there. A couple examples, you heard about these earlier today. 4 facilities that flew in 17 that are on orbit right now. The NanoRacks external CubeSat deployer deploys small sats and CubeSats from the Cygnus at a higher altitude than the ISS. So you can imagine this extends asset life and return on investment for these asset owners. Also, most likely opens up a whole new area of application for many of these assets that perhaps they couldn't tap into deploying from the ISS. Another example is Space Tango's Tango Lab 2, which is the second iteration. There's a Tango Lab 1, Tango Lab 2. This is an internal facility, reconfigurable, multi-purpose, can host interest in every discipline, technology development, and even demonstrate manufacturing in space. Next is Teledyne Brown Engineering's multi-user system for Earth sensing, or MUSES. This is a hosting platform facing back to Earth, pointing at Earth, if you will. Can host 4 payloads, ideal for hosting things like hyperspectral imagers, high-resolution cameras, all sorts of Earth-facing type payloads, also technology demonstration, technology maturation payloads there. Teledyne Brown's open for business. If you got an idea in that area, please contact them. STARS, the Space Technology and Advanced Research System, is once again an internal facility capable of hosting biotech, life sciences materials. Some of its features are temperature control, multi-speed simulated gravity, and they can really get you on orbit in a hurry. They've got a very fast track to get your project in space. As busy as 17 was, things aren't slowing down for the future. Fiscal year 18 and 19, we've got these on the books already. These are manifested. Alpha Space is bringing forward the materials on the ISS Experiment Flight Facility, MISSY-FF. We love acronyms in the industry. The MISSY platform is ideally suited for hosting both active and passive materials payloads, but can also host technology demonstration, technology maturation, and they even have some ideas about hosting biologics in the extreme environments of space. I'm going to learn more about that this week. That could be super cool. Next, Biochip Space Lab, Scorpio 5, a subsidiary of H-Nu Photonics. This is an internal facility, automated live cell and tissue culturing. Fantastic facility. Once again, state of the art. This is a type of technology and the type of capability that people are working with on their benchtops in their ground-based laboratories. And lastly, another facility that NanoRacks is bringing forth, which is the commercial airlock in collaboration with Boeing. It's going to transform how we can transition from the internal, the pressurized volume of the ISS, to the external. I think it's like 4 or 5 times what the current volume is, and I can tell you there's going to be a much higher frequency of companies and researchers having the ability to transition their payloads from inside to outside. So awesome capabilities coming online. Let's now turn and take a little bit of a deep dive into actual utilization metrics and see where we've been, where we are today, and take a look into the future on where we might go. We'll start with up mass and down mass. Basically transportation to and from the ISS. Pretty critical capability. As you could see, Performance in this area, up mass and down mass, has been a bit of a mixed bag. We started out with pretty good progression year over, 14 to 15. Due to some anomalies in fiscal year 15, we had a little bit of a hiccup, but moving into 17, it looks like we're back on the rails and seeing a nice trend line there. But we can do better. We have to do better. There's quite a bit of unused up mass and down mass that we must take advantage of. I personally believe that there are business opportunities in this unused volume and this unused mass. It's going to be a big focus of our team and our group this year to partner with everyone in this room and maybe people we haven't met yet to figure out how do we utilize all of that up mass and down mass, because it's who knows what gold lies there, but we got to figure it out. Next is crew time, and this is sort of taking an analysis of crew time as a percentage of allocation. Now, important to note that, what is allocation? Allocation is the number of crew time hours that NASA assigns to the National Lab, if you will, at increment minus 3 months. So that's 3 months in advance of a certain research planning period, which is roughly 6 months. In advance of that happening, they say, hey, Ken, you've got 400 hours of crew time to go and prioritize and manage and plan your projects against. What this chart suggests is fiscal 14, we don't want to talk about it. Fiscal 15, 16, 17, it took off, and we've seen a nice progression, not only in the crew time that we've utilized against allocation, but I think it's a terrific and positive indication that the allocation itself has continued to increase. And we're in the midst of an increment right now where NASA has provided us with a 4th crew member. Unfortunately, we just have not been able to generate enough projects to consume that additional crew time. So we're going to see a little bit of a downward trend when we take a look at this next year. But to me, this is an indication that the community that's interested in doing microgravity research or space-based research on the ISS, we've got full support of NASA in this particular area of resource. Real actual crew time utilization, you can see here a nice curve, and this is where we're projecting out. And this is a conservative projection. We're saying here 1,700 hours by fiscal year 2022. If you break that down into a 50 or 52 week year, that's only 32, 34, 35 hours a week. So I think this is very conservative. I believe that our partners, commercial partners, OGAs, and our efforts of creating demand, I think we're going to blow through that. We're going to need more crew time hours. Payloads delivered. Maybe this is one of the metrics that we look at is really where the rubber hits the road. It's really the combination of a lot of different types of resources, human resources, assets, hardware, transportation, into the actual project that goes to the ISS. We could see in fiscal year 17, we're reaching an all-time high with 76 payloads being delivered. We've seen a nice transition, once again, a nice growth, and we're anticipating and projecting, once again, very conservatively, pretty much a linear line there, 160 payloads in 2022. I believe the most exciting part of that growth is going to come from our commercial service provider sector. And we're going to work very hard, once again, on that area to make sure that we're enabling those types of activities from that group. It's crucial to what we're doing. Now, is it easy? No. Space is still pretty hard, but as you can see, this is actually a silhouette photograph of one of the PIs today that when their payload launched, they did the happy dance. And that's what it looks like when you overcome some challenges. We'll have a contest to see who can guess who that is. But progress in the face of challenges, it is hard. And operating and managing a laboratory in space has its own unique set of challenges and constraints. But the important takeaway here is to focus on the unique partnerships that we bring together to overcome these challenges. In collaboration with NASA and our commercial service partners and our other government agencies that we're working with and so many other stakeholders, there's no doubt that we've got the talent, experience, knowledge, and desire to overcome any challenges that represent us with operating National Lab in space. And we're certainly going to do our part to contribute to overcoming that so that we're ensuring that looking into the future, we're going to continue to see this progress of resource utilization and value impact. We've got one particular tool that we've developed based on our 5 years of experience in managing and trying to optimize these resources. And we call it the Resource Utilization Planning System, or RUPS, acronym, trademark. What is RUPS? It's very similar to a materials resource planning system that you might have here on the ground in a manufacturing process. It's about optimizing the supply chain logistics that we have that go into planning, managing, and flying payloads. What is it going to do for us? It's going to ensure that we have a standardized nomenclature, a standardized way of unitizing, productizing what is otherwise sort of a daunting thing to look at. When I look at Cindy and our groups out there and I say, Cindy, I need you to utilize 400 hours of crew time and 5,000 kilograms of up mass in 6 months. She goes, what? How do I do that? What's that mean? The resource utilization planning system is going to enable us with a language and really a unitized way of targeting and planning for maximum utilization and maximum impact. Like a for-profit company plans for profit, we have to plan for maximum utilization and maximum impact. That's what RUPS is going to do for us and for our commercial service providers. We intend to share this data. It's going to be an open data source, and we hope that they can use this tool to also target their go-to-market strategies. Where are there opportunities for them to take advantage of open gaps in utilization, near-term opportunities, and long-term opportunities? So basically, it provides us with a very seamless way to integrate all of these otherwise sort of disparate resources and assets and materials that we have at our disposal. Also integrating value impact to make sure that we are creating a diverse community, a diverse portfolio. We need at least 3/4 of the quadrants flying on space station. RUPS is going to help us accomplish that. At the risk of showing you a little too much of the sausage grinding, we're going to take a little bit of a deep dive and show you an example. You heard Cindy talk about the vertical and the vertical strategies. This is an example of one of our verticals and how we have translated sort of raw materials, raw resources in the inventory into a vertical product line. And for now, just focus on the left side of this chart. That's the vertical products that we have in the life sciences vertical. Rodent research, pretty darn complex. So is it realistic to do 10 of those a year? Mary Beth Adina fall out of her chair. Probably only going to do 2 or 3 of those a year. And you go right on down the line, you can see that we have different categories or profiles, if you will, that helped us to characterize what those mean. Do a little bit deeper deep dive, taking as an example a life sciences medium. That might be plant science, drug development, maybe a fairly simple cell culturing experiment. It's about a 10 to 12 month timeline. You see that middle bucket there tells you in general, what does that profile look like with respect to the resources that are required to go and execute that, and then where in the quadrant might you find that? We're in the value impact quadrant. How many of those do we want to go and move in the year? How many of those do we want to see fly in the year to try and utilize all these resources to our maximum benefit? In this example, it's 8. We have examples of these in every category: physical sciences, life sciences, technology, and thank you, remote sensing, of course. And this is dynamic, by the way. This changes. We get together as a working group every month. We analyze where we are. Has the flight program changed? Do we have facilities that are particularly constrained? Do we have something that's broken? Do we have a new facility that's come on orbit that's opened up other opportunities? And so this will give our science and technology, our commercial innovation department, our commercial services providers, and our ops teams to understand how do we in near real time adjust to this dynamic landscape that we live in to assure that we're going to use every bit of resource that we have at our disposal. That's what RUPS is going to do for us. So we're looking forward to evolve this system. We're going to invite a lot of participation in this system moving forward, and the goal is for this to be a real tool that can be utilized by who knows how many different platforms in the future on what assets are flying in space. So thank you for your attention, appreciate it, and we'll look forward to visiting with you later today.